Okay, so this is after the page with the graphic organizer. We're going to complete this in class. So here's the page with negative exponents. We're going to do all the evens in this video, okay? So there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them we're going to do in this video. And then we'll do the other 11 in class, okay? So here's what we're going to write down for the negative exponent rule. If I have some term and I raise it to a negative power, all that negative power does is it puts that underneath 1. It changes it into a reciprocal. It does not change it to a negative term. It changes it to a reciprocal. So it just flips it over. Okay, so we're going to use that to do some of these examples. And they're going to get kind of complicated, but don't worry, I'll walk you through it. Okay. So simplify each of the following. Your answer should contain positive exponents only. You don't want anything with negative exponents. We don't like them. We think they're gross. So 3m to the negative 2. So here's what I want you to think. What is this exponent attached to? Is it attached to the whole 3m, or is it just attached to the m? In this case, since there's no parentheses, it's just attached to the m. So we're going to leave the 3 on top, and the m squared goes on the bottom. And that's it. That's your whole answer. Okay? Let's do number 4. So here we're going to just figure it out. So 6 times negative 3 is negative 18. X to the 8th times x to the negative 7th. So really I'm not flipping this one over. We're just gonna do it. Remember, when I multiply things with the same base, I add their exponents. So 8 plus negative 7 is just 1. So our answer is negative 18x. Okay, and I can go through that one in class again if you need me to. Okay, so number 6. This one is affecting the whole product here. So what we're going to do is we're going to flip it into the denominator. And now this exponent turns positive. But I'm not done. I haven't completely simplified it yet. I need to distribute this exponent to everything in here. So now it's 1 over 5 squared. Y squared times 2, or 2 times 2 is 4. Okay? But now, what's 5 squared? 5 squared is 25. So my completely simplified answer is 1 over 25y to the 4th. Okay? Let's do number 8. So before you flip things over into denominators and stuff, when you're given a multiplication problem, just add your exponents together first and then worry about negatives. Okay, so here's what I mean. So I have a to the negative 5th, b to the 8th, c to the negative 12th, times a to the 7th, b to the negative 3rd, and c to the 7th. I'm going to add the exponents of my like bases. So I'm going to have a to the negative 5 plus 7, because I'm going to add my exponents of my like basis. So negative 5 plus 7 is 2. So that's fine. So I have b, 8 plus negative 3, or 8 minus 3 is 5. Okay. Then I have c, negative 12 plus 7 is negative 5. So I am going to have to flip one of these underneath. It's not a squared, it's not b to the 5th, it's c to the negative 5th. So what I'm going to have to do is put a squared b to the 5th on top, and on the bottom, c to the 5th is going to go. That's a 5. Okay? So it's easier to combine your exponents first and then worry about flipping them underneath. Okay? So let's do number 10. 4x cubed y to the 6th all to the negative 2nd power plus 2x squared y to the 4th to the negative 3rd power. So here's what we're going to do. Since this is a plus and not a multiplication problem, we're going to flip both of these over. We just simply want to get rid of the negative exponents. So we have 1 over, since this negative exponent is outside this parentheses, that means all of this goes on the bottom. Y to the 6th. All squared still. okay, plus 1 over, this is still in parentheses, 2x squared y to the 4th to the 3rd. And that's it. Since if I simplify these two, I'm not going to get like bases, so I can't really combine them, so this is as far as I'm going to go. Because remember, when you add fractions, you have to have the same denominator. There's no way I'm going to get the same denominator here, so we're just going to leave it like that. Okay? Number 12, k to the negative 2nd divided by k to the 7th. So what this is going to look like, instead of flipping this one underneath and worrying about adding it there, I'm just going to use my quotient rule and go k to the negative 2nd minus 7, since when I divide, I subtract exponents. Negative 2 minus 7 is negative 9, which means I'm going to have 1 over k to the 9th power. Okay, so that's my answer for that one. Let's see if we can't do number 14. So whenever I have an expression like this, I want to divide my numbers first. So negative 24 divided by 3 is negative 8. Okay. X to the 5th minus negative 2. So x to the 5th, remember I'm using my quotient rule, 5 minus negative 2. I'm actually going to end up adding these together because 5 minus negative turns into a positive. So I have negative 8x, 5 plus 2 is 7. Okay, so that's my whole answer. So really when you're doing these, you're going to divide numbers first and then worry about adding your exponents, okay? So let's do number 16 so you can see what that one is. So we're going to use our quotient rule, which means I subtract my exponents from my like bases. Okay, so I have x to the 4th minus 2, okay, times y to the negative 3 minus 2. I'm using my quotient rule that I learned on the previous page. So I have 4 minus 2 is 2. Negative 3 minus 2 is negative 5, which means I'm going to have x squared on top and y to the 5th on the bottom. Okay. So you can apply the quotient rule separately and still combine them at the end. Okay. Number 18. We have this one and then we'll have one more and then we'll be done. So divide your numbers first. 36 divided by 12 is 3. X to the negative 4th. There's nothing on the bottom to subtract from it, so that's cool. Y to the 8th minus 7, using my quotient rule. So since x has a negative exponent, that's going to go on the bottom. But since y doesn't, 8 minus 7 is positive 1. That just means you're going to have 3y on top with your x to the 4th on the bottom. So that's your whole answer for that one. Okay. And we have one more. Let's see if we can do this. This is going to be fun. Okay. Negative 4 divided by 8 is not negative 2. Do not tell me it's negative 2. Negative 4 divided by 8 is negative 1/2, because 4 is half of 8. Okay. P, remember when there's no exponent, we put a little 1, to the 1 minus 2. Q, 5 minus 2. R, 3 minus 10. Let's see what happens. So I have negative 1 over 2. I'm making it long because I know some things are going to go on the bottom. 1 minus 2 is negative 1, which means I'm going to have 1p on the bottom. 5 minus 2 is 3, positive 3, so I'm going to have q cubed on top. 3 minus 10 is negative 7, so I'm going to have r to the 7th on the bottom. And that's my whole answer right there. So when you're doing these, divide your numbers first, apply the rules, apply the quotient rule, subtract your exponents, and then figure out where they go. Okay, so that's the easiest way to do this. All right, so that's all the examples we're going to do in the video. We're going to fill out the graphic organizer in class, and then we'll do the odds of all of these in class too. Okay?